Good morning, this is Kasturi Day. Again, I've come to discuss the language of chemistry chapter according to ICSE syllabus class 8. Okay, so in my last video of this subject, that is in chemistry and then this language of chemistry chapter, I discussed the valency and uh, the the chemical symbols of the elements. Okay, now today I'm going to continue with the valency only. It is assumptions in finding the valency of elements. What are the assumptions that are taken to find when we find the valency of the elements? The first one is the valency of hydrogen and all metals is considered to be positive. Okay, so when we are finding the valency of the elements, the valency of hydrogen and all the metals, they are considered to be positive. Then valency of all the non-metals except hydrogen. Okay, as hydrogen has a positive valency, so non-metals, excuse me, the non-metals, all the valencies of the non-metals, that is all the non-metals, they are considered to be negative except hydrogen. Okay, as the molecules of a compound is electrically neutral. Okay, it is assumed that the positive valency in its molecules is equal to negative valency, total negative valency. As a molecule of a compound is electrically neutral, when it is considered as a molecule, it is considered that it is electrically neutral. Okay, so it is assumed that positive valency in its molecule, the valency which is positive in the molecule, that is equal to its negative valency. That's why positive and negative, that becomes neutral. Okay, how much negative valency is there, that much of positive valency is also present in the molecule. Therefore, that becomes electrically neutral. That is why it becomes electrically neutral when it is considered as a whole. Then, for example, in a compound of HCl, one atom of hydrogen combines with one atom of chlorine. So hydrogen is positive. Okay, we know that hydrogen valency is positive, considered as positive. So the chlorine is also considered as negative and also having a -1 valency. Like that, in hydrogen it is positive, so +1, and therefore chlorine has -1. Therefore, HCl as a whole, when it is considered as one molecule of the compound, it is considered to be electrically neutral. Okay. In the compound H2S, two atoms of hydrogen combine with one atom of sulfur. Okay. So what happens? Two atoms of hydrogen, though that is why it is having my +2 valency. Okay, +1, that is +1, two atoms, that's why it is +1 and +1, that is +2. Okay, I mean the valency becomes 2. I'm sorry, the atoms, the hydrogen atom is considered to be +1 +1. Two atoms, as it is two atoms, it is +1 and +1. Okay, so in the sulfur also, it has the valency as -2. Okay, that equalizes the hydrogen two atoms having +1 and +1 valencies of two atoms of hydrogen. So +2, and here it is -2. So electrically it becomes neutral when it is considered as a whole compound, one molecule of the whole compound, that is H2S. Okay. Next is variable valency. Now certain metals rather, exhibit more than one valency. They exhibit variable, that is variable valency. Okay, more than one valency, one compound, one metal having more than one valency, that is variable valency. The reason is that why this happens, because that depends upon the experimental conditions. That is, an atom of the metal loses more electrons that are present in its outermost, that is the valence shell. The shell which is in the outermost the outermost shell which has electrons, those electrons are called valence electrons, and the outermost shell is known as valence shell. Okay, so an atom of the metal loses more electrons from its valence shell, and therefore that is, it loses some electrons from the shell next to the outermost shell also, thus exhibiting variable valency. What happens? From the outermost shell, there it loses electrons, that those are free electrons, you can say. And sometimes what happens, it loses electrons from its penultimate shell, that is next to the outermost shell. Okay, that is also it is losing electrons from that shell also. So that is why they exhibit variable valency. For example, an atom of iron has 2 electrons in its outermost shell. On losing these 2 electrons, it exhibits a valency of +2. But sometimes it managed to lose electrons from its penultimate shell, one more electron from its penultimate shell. That time its valency becomes +3. Okay, so it has 2 electrons on its outermost shell, free electrons are 2. Okay, it loses its electrons and becomes +2 valency. But when it loses its electron, one more electron, that is 2 it loses, but still one more electrons it loses from its penultimate shell, that is next shell after the outermost shell. Okay, so that time also what happens, the valency it becomes +3. Okay, for naming such elements which has lower valency, the suffix used is us, O-U-S. And for the elements which has higher valency, that is the same metal, if it is lower valency, it has the suffix used for naming it, it is used as O-U-S. Suffix is added to it. And when it is in higher valency, it suffix IC is added and to name the element. Okay, so these days, instead of this suffix OUS and IC, the valencies are written in Roman numerals under the brackets beside the names of the element. For example, iron, when it is at lower valency, it is known as ferrous. Okay, that is OUS suffix is added here. And if it is in the higher valency, it has the suffix IC, that is ferric it becomes. Okay, but nowadays what happens, ferrous is written as iron in the bracket 2, Roman numerals 2. And in case of ferric, the this iron, it is named as iron in the bracket 3. Okay, Roman numerals in the bracket, it is written as 3. Nowadays this is happening. Okay, now some non-metals also exhibit this variable valency. For example, nitrogen, phosphorus, sulfur, these all exhibit this variable valencies. Okay, now sulfur has valencies, 3 valencies it has, 2, 4 and 6. Okay. See, these are the elements, that is aluminium, which has a symbol of Al and valency 3. Then zinc has Zn, it is the symbol is Zn, and it has 2 valencies, 1 and 2. Copper, zinc has 2 and copper has 2 valencies, is 1 and 2. That is cuprous and cupric. Okay, so nowadays it is written as copper, that is Cu in the bracket 1, Roman numerals 1, and this one for cupric, that is for 2 valency, it is known as Cu, that is 2 valency. Okay, then silver Au, gold Au, that is has 1 valency, silver Ag has 1 valency, then barium Ba, it has 2 valency, chromium Cr, it has 3 and 6, then manganese Mn, it has 2, 4 and 7, magnesium Mg, it has 2, then calcium, it has 2, then Ca, that is it is symbol is Ca, lead Pb, it is known as plumbum or Pb, 2 and 4, sodium Na, it has 1, potassium K, it has 1, then cobalt capital C small o, 2 and 3, lithium L capital I, L and small I, it is 1, then beryllium Be, it has 2, then nickel Ni 2 and 4, iron Fe 2 and 3, mercury Ag 1 and 2, tin Sn, that is 2 and 4. Then oxygen, these are the non-metals. Previously they were metallic elements. Now we are coming to non-metallic elements. Here oxygen O has 2, nitrogen N has 3 and 5, carbon C 2 and 4, fluorine F 1, chlorine Cl 1, bromine Br 1, iodine I 1, boron B 3, sulfur S 2, 4 and 6, phosphorus P 3 and 5, silicon Si, that's 4, helium, neon and argon, these are inert gases. They do not have any free electrons. That's why they are inert gases and their valency is 0. Okay. Next we come to radicals. A radical, what is a radical? It is an atom of an element or group of atoms of different elements. It's either one single element, one atom of a single element or a group of atoms of different elements that behaves as a single unit with a positive or negative charge on it. Okay. It's a positive unit with a positive or negative charge on it. Okay, it behaves as a single unit, like ammonium, NH4, ammonium radical, it is NH4. Two different elements are there, one atom of nitrogen and 4 atoms of hydrogen are there. Okay, and that behaves as a that has a positive charge. Okay, carbonate, C and O, because this carbon and oxygen, one atom of carbon and 3 atoms of oxygen are there, and they behave as a negative radical, negative charge. Okay, there are 2 radicals, basic radical and acid radical. Basic radicals, they have positive charge on it and they are also called cations. Example are all metallic ions, and ammonium ions are all cations or basic radicals. Okay, then acid radicals, they have negative charge on it and they are also known as anions. Mostly they are non-metallic ions, and group of non-metallic ions with a negative charge, they all act as acid radicals. Okay, see, these are the examples of the cations and anions. That is, there is acid radicals and basic radicals and acid radicals. Okay, please go through the chart and you will be able to understand these. Okay, so and this is also the chart of the valency with monovalent, bivalent and trivalent compound. These radicals are there. Okay, please go through this once. If you face any doubt, please do write in the comment box. I'll be explaining it to you. Okay, so next will be molecular formula of compounds. Okay, it is a symbolic representation of its molecules, showing the number of atoms which are present of each element which are present in it. Okay, it's a symbolic representation, that is, the molecules are represented with symbols. These atoms combine in whole numbers to form a molecule. Okay, for example, a molecule of sulfur dioxide, it contains the symbols of the molecule, symbols of sulfur and oxygen. Okay, with their valency. So it indicates one atom of a molecule of sulfur dioxide. Okay, that is formed by one atom of element sulfur and 2 atoms of oxygen. So as the formula of a compound represents the molecule of a compound, so it is more commonly called a molecular formula. Okay, as the formula of a compound, this SO2, that is a formula of a compound, but as it represents one molecule of a compound, therefore it is more known as, it's appropriately known as molecular formula. Okay, so I'll discuss in my next video how to write these formulas. Okay, so please go through this. If you have any doubt, please do write in the comment box. I'll try to explain it to you once more. And if you have any if you like the video, press the like button, share with your friends so that they can also be benefited from these videos. And also do subscribe and do comment. Okay, so that you can get the notification of my next video. Okay, thank you for watching. Have a good day.